Okay, good morning everyone. So today we're looking at the electrolysis of water. So I'm just going to follow along in your note package. So firstly, the definition of electrolysis, right? So we have electrolysis is a process that uses electricity to break down water into its elements. So we all know that water is essentially H2O, right? So when you're looking at this, H2O is comprised of two different elements, right? We have capital H, capital O, so hydrogen and oxygen. So essentially water is a compound, but we can actually break it down into the individual elements that it's made up of. So this process needs electricity in order for this to happen. So essentially we need to put in energy, and the energy type that's being used here is electricity. Okay, so essentially what this would look like, if we were to write out the formula, right? So we have water breaking down into, and actually how this appears is hydrogen and oxygen gas. So right now, the only one you would really know is water and oxygen, because we've seen these two both in cellular respiration and photosynthesis. Right now, don't worry so much about why, like how do you know if there's a 2 here, or how do you know what the numbers are down here. Later on in the chemistry unit, like we will go through and you will learn how to basically know how many of each element there are. For now, I just want you to know this process. So water is breaking down into hydrogen and oxygen. Okay, so we're going to start taking a look at what do we use to actually go ahead and do this. So the piece of equipment that's used to do this electrolysis is called a Hoffman apparatus. So it's kind of a weird looking instrument, but all of this component that you see here, that I'm kind of outlining, is made up of glass. So it's kind of like the same material that a test tube would be made of, except it's a kind of a weird shape. So all of this, you have to imagine, is filled with water. Okay, so let me just kind of fill this in. So like this part here, I'm doing a fantastic job here, but you have to imagine, and it even tells you here, right? Acidified water is inside of this tube, and it kind of fills in both of these sections. Okay, hopefully that kind of helps you a little bit. Anyways, so we have water that is inside of this tube, and you actually pour it in this way. And we do have to have it slightly acidic. Okay, and the reason why is because electricity, okay, so we're going to use a battery here to actually run through the water. So water by itself actually cannot conduct electricity. So meaning water cannot have electricity pass through it on its own. It needs to have something dissolved within it. Okay, so that can be done in a few different ways. You can add in a salt. So, even something like table salt, sodium chloride, or you can add in an acid. Now, we're not talking about super acidic solution here. Even just a few drops of an acid is enough. Basically, you want to just add enough so that electricity can flow through the water and do the job that we need it to do, which is to break down into hydrogen and oxygen gas. Okay, so you'll see that the battery hookup is here. Now, there's two kind of sections on the left and right hand side of where the water's poured in, and they are there for a reason. The two different gases, so let's go back for a second. So we're making hydrogen and oxygen. Both of these are gases that are made. Right? So remember, water is a liquid, but the products of this reaction are gases. So we have to have a spot for the gas to essentially fill up. And that's what's happening here. So there's a gas that's being produced on this side. So see how it's like empty, there's no water there? It's because in here there's a gas. On the other side, we also have a gas. So one of these sides is oxygen, and one of these sides is hydrogen. So we'll talk about which one is which later on. And then of course you'll see there's these little valves. Those valves are there so basically we can open and close it, so we can let the gas out if we want, or we can keep it closed and keep the gas inside. Okay, I do have a video linked to show you how this exactly works. Like obviously not just like a cartoon drawing of it. So you'll check that out after you fill in your notes here. Okay, so let's go through the questions. So what kind of electricity, what kind of energy does electrolysis use? We're kind of answering our own question here, right? So this is electricity, right? And that's what we had already gone through at the beginning, right? Part of the definition. The water is blank this energy. Okay, so the water is decomposing with this energy, or we can say the water is using this energy, right? So we're going to write in here, the water is using this energy. You can even say the water is absorbing this energy, but essentially the water is going to be using that electricity we're putting in order to do the decomposition or like the electrolysis breakdown of water. So the formula of water, we already know this, the formula of water is H2O. Okay, so let's take a look. This formula tells us that the water molecule has more blank atoms than blank atoms. So what we're doing is we're going to be looking at the number of atoms that are here. So hydrogen has the 2 there, but oxygen does not have a number. So if you remember, we did talk about this when we looked at photosynthesis. If there's no number there, it's almost like as if there's a little imaginary number 1. So by looking at the 2, the ratio here, we have more hydrogen atoms than we do oxygen. Actually, we have twice as many. So we have more hydrogen atoms. Forgive me, I'm writing with a mouse, so it's a little bit difficult. But we have more hydrogen atoms than we do oxygen atoms. Right? We can see that from the formula. Okay, so a water molecule has blank as many hydrogen atoms as oxygen atoms. So we're looking at a ratio here. So there's twice as many. So we have twice as many hydrogens in comparison to the number of oxygens, right? A water molecule has blank as many oxygen atoms as hydrogen atoms. So if we're comparing the other way, there is half as many oxygens as there are hydrogens. Right? Because the ratio is 2 to 1. Hopefully that's making sense so far. Okay, so now that we're looking and we know the ratio, so we talked about essentially H2O, there is 2 hydrogens for every 1 oxygen. So now when you're looking at this picture, remember these sides is where the gas is being collected. So by looking at the volume of the gas collected, we can actually start to predict which one is our hydrogen side and which one is our oxygen side, because we know there should really be twice as much hydrogen gas as there is oxygen gas. So in this picture, now that I've written all over it, but in this picture, we can see that the left side of the picture we're looking at has more gas than the right side. So if we had to look at this picture and identify which one is which, I would say that the right side is oxygen, right? Because there's less gas, and the left side has more gas. So we have hydrogen. So this actually should be technically a 2 to 1 ratio. So let's say there was, let's say we gave numbers to this. If there was 10 milliliters of hydrogen gas, there should be 5 milliliters of oxygen gas, right? Like it's a 2 to 1 ratio. So filling this in here, so oxygen is collecting on the right side, and then our hydrogen, of course, is on the opposite side. It's the left side. Okay, so that's the end of our electrolysis kind of outline. So you should be able to predict at this point the ratio of hydrogen to oxygen, right? So like the volume amounts. You should understand what electrolysis is and essentially kind of the setup of this Hoffman apparatus. Okay, so be sure to check out that video that shows this in use.